essential question. Can I graph good timing. Can I graph exponential growth and decay? They're functions, actually. All right, so that's the first part. And then just like we did with cube root and square root models, John, get your notes out, take notes. Just like we did with those functions, can I state the domain and range of each? I'm going to add something to this. I'm going to say domain, range, and asymptotes. What? Asymptotes. Anybody know what an asymptote is? I don't think we've hit it yet.
Like this girl at my home asked me what the answer was to something, and I was like, I have no idea.
Yeah, what it is. I know. It is. We'll talk more about this. An asymptote is
a line that.
I know, Christian, that you can read what it says on the page. An asymptote is a line. An imaginary line. We'll do it with a dotted line. A lot of times it's on the x-axis, so you won't see that dotted line, but we'll have some examples that aren't. So it's designated with an imaginary dotted line. It is a value that your function, your actual graph, will approach, so like get really close, but can never actually have that value. So if I have an asymptote at y equals 0, which is my x-axis, right, I can get very, very close to 0, actually infinitely close to 0, like 0.00000 and any number of zeros up to infinite 1, but I can never actually technically have a value of 0. So we'll see it in action. The parent functions for exponential growth and decay start with growth, and then we'll go through that and do some example problems. Then we'll do decay. So these are parent functions like you had with the parent function for square root of x. Our phones, Pastor, what is happening? What is it like?
We're all curious about the teacher pay vacation question.
No,
you just won't answer.
You can wait till the end. I don't actually know. All right. Parent functions, guys. I'm going to define exponential growth as f of x equals b raised up to the x. So the first thing you notice, one, there's two variables in this. One of them is b, one of them is x. One of them is x. Give notes. We'll talk about it later.
How do you feel?
Yeah, not great. Okay, b to the x. First thing you notice, my x is a variable, and it's in the exponent now, right? So I'm actually going to be changing the power that I'm raised to. So for exponential growth, I'm going to have b to the x, and specifically, I'm going to say that b has to be greater than 1. All right? So anytime we have a problem, you have x in the variable, and the number being raised to x is greater than 1, you have exponential growth. That's one way of defining this. The other way of defining this is exponential growth. Let's say this. Is it as x increases? All right, look at my parent function. As x increases, what happens to y? It also increases. It doesn't just increase, though. And this is going to sound crazy. It increases at an increasing rate. Whoa, I know, right? So as x goes up, y goes up. It's going up, right? The arrow is pointing that way. But it's going up, look, from I go here to here, okay, it's increased that much. So if I go here to here, it's increased that much. Every x that I go along, it's getting bigger by more. So that's really what we mean by exponential growth. You remember the problem, probably did in middle school. Brent, would you rather have, I'll give you $1 each day for the next 10 years, it's $1, or I can give you a penny now. Tomorrow I'll give you 2 pennies. Yeah, you say that you already know, it's 2 the penny one. And the pennies I don't just give you 1 more penny each day. I'm actually doubling the amount of pennies, right? So 1 penny becomes 2, 2 penny becomes 4, 4 becomes 8. No, 16, sorry.
Yeah, I was like,
Not
16.
not doubling each time. It becomes, that's the exponential growth, right? I know.
thought I was
No,
wrong.
you were right. No, I clearly didn't know what I was
Oh
talking
my
about.
god.
So as x increases, y increases. Yeah, it's always being squared. So 4 squared is 16. 16 squared is a big number you can calculate, or whatever that neighborhood is squared. And immediately we're making a real number, right? So always take steps. So here on this parent function, guys, we see our first asymptote. Our first line that the graph approaches but never hits. If I'm coming down this way, right, it's a pretty bad drawing because it looks like it touches the x-axis. It looks like it touches 0. Keep in mind, in this section, in this chapter, I'm not grading you on your graphing ability. If your line comes through and touches your asymptote there where you draw it, I'm not going to take off. If you've shown me you know where it is, you know, and I don't care if the line actually touches it. As long as you can show me, in theory, you know what it means. So let's, if you're going, well, I get what an asymptote is, I don't get why it exists. Let's graph one. So graph each function, state the domain and range for the function. Is this exactly like the problems we just had? I'm going to give you a function, graph it, give me domain and range, right? The only other thing, state the asymptote, and we'll talk about how to do that. So y equals 3 to the x. What was our first step in graphing last chapter? What? That was if I wanted to find an inverse. So I just
Make a t-chart.
Yeah, just make a chart with x and y values, right? Like that, right? Plug in x and find a y. The hard part is knowing what to plug in for x. That's gone now, and it's super easy. You can plug in anything for x. I'm going to recommend you do -2, -1, 0, 1, and 2. That gives you 5 points. They're very easy. Since you're raising up to an exponent, easy exponents to do are raised to a 0 power, raised to the first power, and just squaring something, right? That'll give you plenty of points. You're going to want to do at least 5. Yes. Yeah. And you'll see why. Otherwise, you won't get a clear idea of where the asymptote is. I would do at least 5 points, guys. So.
Do some have to be bigger?
Yes. Yeah, you need negative ones. Again, you'll see why the negative ones show me where the negative ones show me where the asymptotes are, Lucky. So let's start with 0. Plug in 0 for x. That's 3 to the 0 power. Yeah, anything to a 0 power is 1, right? Okay, and then that's it. So now let's go to 1. What's 3 to the first power? 3. And then 3 to the second power is 3 squared, which is 9. Awesome. So that's pretty easy. Now let's work backwards. 3 to the negative first power. Lord, what do I do with that negative exponent? I flip it to get rid of it, right? So this becomes 1 over 3 to the first, which is just 1/3, right? Good. Let's do the next one. 3 up to negative second power. Trent? Flip it. 1 over 3 squared, which is 1/9. Good. If I wanted to do one more, let's say 1 over, or 3 to the negative third power, that'd be 1 over 3 cubed, right? Which would be 1 over 27, which is a very small number, but not 0, right? So I would keep getting smaller. So let's plot these. Let's graph them. I've got an x, so 0 and 1. I'm going to go up 1 and 3, 2 and 9. Okay. Negative 1 and 1/3. Good luck graphing that. And negative 2 and 1/9. Forget about it. Imagine if I had done the one before, 1/27. You see what I mean? I'm not going to judge you on your graphing on this. However, I will judge you on your ability to tell me that my asymptote is right here at y equals 0. Right? No matter how negative my x's are, negative 10, negative 50, negative 1,000, negative 1,000,000, I'm never going to actually equal 0, because I'm always going to flip it to get rid of my negative, and it's going to be 1 over a number. as long as that number isn't 0, which it can't be, right, I'm going to have something that is bigger than 0. So the asymptote, you don't have a blue pencil, which you won't, that's fine. You don't really need to give me that dotted line. You can just state the domain, range, and the asymptote here. So domain of this function, is x limited in any way? Does it go, no? Anybody think otherwise? What? Is x limited, or am I all real numbers? All real numbers, right? It looks a little weird because this guy seems like it starts going straight up.
Did you have to say that? Oh, wait, never mind. That's what you said.
Anyways. But it definitely goes to negative infinity, like for sure, right? And also positive infinity. So domain is all real numbers. Range. Lucky, what do you think?
Y is greater than 0.
Yeah, I definitely have to be greater than 0, right? So I know I'm never going to hit 0. So it's not, keep in mind, y greater than 0, he didn't say greater or equal to, right? If I was equal to 0, that means I wouldn't have an asymptote. It means I could have the value of 0, but I can't. And then super simple, you can just write out, you have an asymptote, p in it, at y equals 0. You could do that. I like to abbreviate it actually. It's a horizontal asymptote, right? So HA. If I had a vertical one, which we'll get to much later, I would write VA, vertical asymptote.
You have to y equals 0 for this one.
Yeah, that's where it is. So it's an imaginary line, right? So the line is y equals 0.
Okay.
Constant value. We'll see how the asymptote can move up and down. We'll see that in later sections. So guys, all we're doing here, we're just plugging in values, plugging, solving, graphing. The big thing here is the asymptote, right? And domain and range. I'm going to be erasing this only because I need this space to work. I'm going to give myself enough.
Are we going to get to asymptotes that are like diagonal and stuff?
No, not even in like trig, and I don't think in college algebra. All your asymptotes, you have repeating asymptotes in trig, but they'll be all vertical or all horizontal. Okay, next one, same thing, x and y, guys. I'm going to plug in the same numbers, -2, -1, 0, 1, and 2. Notice here, what did I say my b value had to be in order to have exponential growth? Had to be greater than 1, right? B greater than 1. On b, is b greater than 1? Yeah, it still is. I know it's being multiplied by that 1/3, but it's getting that after it's raised to an exponent. So that value 3, b, up to the x is still greater than 1. Okay. So let's plug in. Let's start at 0. 3 to the 0 power. 1 times 1/3. 1/3. All right, 1. So 3 to the first power. 3 times 1/3. 3 times 1/3.
1.
1. So plug in 2. 3 squared.
3.
9 and times 1/3.
3.
That's 3. Thank you, Lucky.
-1.
-1. All right, so let's write this one out. 3 to the negative first is the same as 1/3, right? Times 1/3. Multiply across, right? 1/9.
Yes.
We're not gonna
You what? Yeah. All right, next one. 3 to the -2 power is the same as 1/3 squared, which is 1/9, times 1/3. 1/27.
Why would it be 3?
I gotta wait. What's up?
How are you supposed to graph 5.8?
So all I'm doing is taking my x and plugging in, right? Well then, and so it's 3 to this power. But then I have to multiply that by 1/3. That makes sense. I kind of switched it. This 1/3 is technically over here, right? But it's all just being multiplied. Good. So let's plot this, guys. If graphing on the if graphing on the last one was hard, this one's going to be impossible.
Just make like a straight line to 1, 1.
I got 2, 3. Can't see that at all. I've got 1, 1. 0 and 1/3. -1 and 1/9. -2 and a little bit lower there. 1/27, right? Again, folks, that's just the 1/27. That's impossible to distinguish from 1/9 from your hand graphic. I totally get that. So I'm not super worried about that. I'm just going to draw a nice line here and going up, and then draw my asymptote where? Christian, y = 0. Again, I have the benefit of a smart board and a blue pen. That's okay. Domain and range here. Domain? All real numbers, good. If you're noticing a theme, 95% sure everything in this chapter is all real numbers for your domain. I'm pretty sure. At least for this section of it, I know that. Range. Bolton, what do you got? What do you think is the range restricted here? Think about the last one. What? All right, so go up here. Are all my range? What does my range have to be greater than? 0. Good. So it can't be negative. So y is greater than 0, right? For my restricted range. And asymptote, again, I'm just going to put HA because it's a horizontal asymptote at y = 0. Cool. Exponential decay. We notate it the same way, guys. F of x equals b up to x. That's exactly the same as exponential growth, right? Just a number raised to my exponent, which is a variable, right? But here, b has to be between 0 and 1. Notice that this is where it can get a little confusing. I'm not saying that growth is greater than 1 and decay is less than 1. I'm saying growth is greater than 1, decay is between 0 and 1. That can come as a decimal, that can come as a fraction. We'll see both. So it could be 0.75 raised to the x power. It could be 3/4 raised to the x power. It could be 1/9 raised to the x power. As long as it's between 0 and 1. Yep. It's basically, guys, it kind of looks like it's just flipped across the x-axis, right? So we could say for this guy, as x increases, what happens to y?
It increases.
Okay, so on this one, on range, is it going to be in the same thing right there? Like
Yes,
y
they're
here?
both the same, right? Because my asymptote is still at y = 0, and I need to be greater than 0.
Okay.
So it's just all positive y. Good. As x increases, what happens to y? What happens to y? It decreases. And guys, just as I described exponential growth as increasing at an increasing rate, just in time. So the first page. Alright, so just as with exponential growth, it increases at an increasing rate, I am decreasing at a decreasing rate. Okay, decreasing at a decreasing rate. Look, as x increases, First, I'm jumping down really quick, right? And then I kind of level off. Exponential decay, we'll talk about with a lot like populations. See all kinds of like biology questions on like some kind of fungus dying in a forest, and then the population going. I don't know. We'll see problems like that. So growth, we'll talk about populations as well, but we'll mostly talk about interest and like money, which should be fun. So same thing with this domain. On this guy, still all real numbers. Range is still y equals greater than 0, guys. I still have a horizontal asymptote and y equals 0. All right. So, graph each function, state domain and range, state the asymptote of the graph. Same thing, right? All right, so look at question A. Is that exponential growth or decay? Growth or decay? If you think it's growth, raise your hand.
Wait, I can't
If
see
you
it.
think it's
You're in the way.
If you think it's decay, raise your hand.
Oh, no. Okay.
Christian raised his hand twice, so Colton.
I changed
Don,
my
why do you
answer.
think it's exponential decay?
It's greater than 0.
Greater than 0, but less than 1, right?
Oh.
1/4 is greater than 0, but less than 1. If it was greater than 1, I would have growth.
What if it's 1?
It's a fraction or a decimal, right? But it can't pick a negative. Like it throws off. 'Cause a negative number is less than 0, right? All right, so let's graph it. Actually, what's my first step when I'm graphing? T-chart, good. X and Y values. X and Y values. I'll use my recommended numbers. -2 up to 2. Right? So plugging that in. Start with 0. I just always start with 0. What's 1/4 up to the 0? 1. Always 1, right? Anything raised to the 0 power is 1. Alright, 1/4 up to the first power. 1/4, good. Billy, how you doing? Doing alright? I got like 3 empty chairs up there. I like this one too.
I just gave you that answer.
I didn't say Amelia, I said Jillian. But when both of you look up guilty like that. Alright, squared, guys, 1/4 squared. I can write that as 1/4 times 1/4, or I can write that as 1 squared over 4 squared. Either way, 1/16, right? Alright, negative gets fun. 1/4 raised to the negative first power.
It's 4.
Yeah, what do I do with that?
You have
Negative.
to flip it.
Flip it, right? So this is 4 to the first, which is 4. Alright, so 1/4 raised to the negative squared power. Again, flip it, becomes 4. And what's 4 squared? 16. Yeah. Alright, so plot these points. -2 and 16 I don't really have. It's way up there, right? -1 and 4. 0, 1. Oh, 0, 1. 0, 1. 1 and 1/4. 2 and 1/16. Can't see my thing. Relax. Well, we'll say we're going on that way. Yes. Oh, no, question. Guys, on the next one, well, hold on, I'll just cross that bridge when we come to it. So, domain, all real numbers, good. Range, Anna, what you got? Less than 0, yeah, less than 0 would be down here, good. And I have a horizontal asymptote where? y equals 0.
So the x-axis.
It is. The x-axis. No, just above it is all where all my values are. The asymptote, guys, so just to clear up some confusion, the asymptote is the imaginary line that I actually can't touch. So I get close to it. So the line I can't touch is at y equals 0, right, Alex? 0 is the value I can't have. So I put my line where I actually can't have it. So do not touch it. Do not cross it. Yes. Yes. Yeah, but it's like this next part. Right now they've all been on the x-axis. Once we get this translations, you'll see it. That'll probably actually help people see it a little bit. Cool. All right. Last one, and then we do some translations.
Wait, I think, what was the 2 value?
What was the what? The value for 2?
Yeah.
1/16, right?
I think.
All right. So let me stop here and say that everything up to this point, you can fully expect to see on a test or quiz with no calculus. That's absolutely all math we could do in our heads, right? The biggest thing you had to do was 3 squared, which is 9, right?
I just went through
Yeah, but again, the non-graphing, right? Fair enough. Here would be a little bit different. So same thing, -2, -1, 0, 1, 2.
Are we always going to use
You guys, this is one example where you may want to use another x value. I'll show you why. Sometimes plugging in -2 up to 2. Oh, promise. Great. Can't go around and applaud every person for not talking. Jameson, you're doing a really good job. Just don't talk. So when I plug in these numbers, sometimes, guys, you won't get a clear idea of where the asymptote is. You'll get a hint at it, but you're going to want to get some more confirmation, so you'll plug in more numbers. So plug in 0. 2/5 up to the 0 power is 1. Anything up to 0 is 1. Times -3, -3, right? Do the rest of these on your own. Fill it out by yourself with these 4 values. Go. You're going to want to use your calculator. You can do fractions and or decimals. I prefer decimals. That's literally just me. I have no preference in terms of grading what you do. I would use decimals. That's what I would do, but if you want to leave them as fractions, it's totally fine. Yeah. What would you do? Those won't reduce a lot, right? So they're fractions or decimals. Change the fraction to decimals. No, that's changing the fraction. You want to change this. Yep. And that you can't even change, but I'll change that fraction to that.
Is this where I'm doing with
Yeah.
Yeah. You good? You know what we're doing?
funny, let's go. You don't even have to do the first one. Oh, it's the last one.
Did you get to the line? Okay, that's what
Check your negative signs.
It's not gonna get any harder.
Yeah, you're close.
That's math.
Okay, wait, Mr. Jackson. Sorry.
Saying that. Well, you plugged in. Right.
Times -3 is negative.
Okay.
Okay, my question was like the last one is like -0.48. Can you just put 0.5 or no?
No. Now, when you're actually graphing it, yes, right, it's basically going to put it right in the middle of the two lines. But no, we're writing our chart, I can do that. Good. So here's the problem with this one. If I graph this, guys, -2, -18 something, that's huge, right? We'll put that here. -1, can't see, 1, 2, 3, 4, 5, 6, there. Nope, it was awful. 0, -3, 1, -1.2, 2, -1/2. Guys, here's the problem with this. I don't really get a clear idea where my asymptote is. So keep going. Plug in 3. Plug in 3 and tell me what you get. Yes. Yeah, so you'll see that in the next step down here on the graph. Why that is. But for now, plug in 3, tell me what you get. Lauren, what'd you get when you plugged in 3? You needed to do 3, right?
I'm sorry, I got all the rest of it.
Good. But
I got it.
you promised.
Oh, wait. I didn't do 192.
Oh, negative, right?
Negative.
Good, so negative 0.1. So guys, where do I think my asymptote is here? Still at 0. So if I'm going to graph this sucker,
I don't like all the decimals.
alright, so for domain, still all real numbers. Range, y has to be less than 0. Notice, guys, and we'll get into translations momentarily, but when my a value, my coefficient, is negative, what happened? I flipped across the x-axis, just like with my square root functions and cubic root functions. So y has to be less than 0, and I have a horizontal asymptote. So that, and y equals 0. Yeah. All right. Recording through that whole thing. This video is just makes perfect because these videos are so long. All right, I need to erase this so I've got some room to work. So the way, stay with me here. The way I'm going to write out the full equation that we're going to deal with for exponential growth and decay is f of x equals, all right, a times b to the x, and that exponent is x minus h plus k. That's the whole thing. A will tell me just kind of how it's similar with cubic and square root functions. Will tell me if it's wider, if it grows faster or slower, right? It will also, depending on whether it's positive or negative, it can flip me across the x-axis. So that's the same, and we just saw that, right? H will still move me horizontally. Notice that just like on this last one, H, we changed the sign on it. So a positive H moves me left, and a negative H moves me right. So if H is horizontal, that means K translates me what?
Vertically.
Vertically, and we don't change the sign on that. Okay? K is the only thing that's going to move your asymptote up and down. We're always going to deal with horizontal, and K is the only thing that'll move it. So that's your whole form for it.
Is your K always going to be your asymptote?
Yes, actually. Yes. So graph each function, state the domain and range, state the asymptote and graph. Let's go with A. Yes. Oh, you mean on that? Yeah, good. Yeah, if you want to go ahead and work it out, that's fine. Alex, what's the first step? Always when I'm graphing? Yeah, get a little chart going. So x and y, -2, -1, 0, 1, and 2. Plug in 0 for x. So 2 to the 0 minus 1 power. That's 2 to what power? -1, right? So this is the negative first power. So 2 to the negative first power is 2 to the negative first. That's 1/2, right? So 1/2 times 4. What is it, Christian? I know. 1/2 times 4?
1/2 times 4 is
2. Very good. So 2 minus 3, -1. All right, plug in 1 for x. 2 to the 1 minus 1. That's 2 to what power?
0.
Good. 2 to 0, which is 1.
4.
1 times 4 is 4. And 4 minus 3 is +1. Plug in 2 for x. So 2 minus 1. 1. Okay, so 2 to the first power. It does make me mad. Make me curious. Put it away. 2 to the first power, Lauren.
2 what?
2 to the first power.
2 wait, what?
What is 2 to the
Oh,
first?
it's
Oh, I was so confused. You want me to plug in?
I wanted you to plug in 2.
Oh,
2 minus 1 is
2 minus 1 is 2, that's 2.
It's
2. Good. 2 times 4,
8.
8. 8 minus 3.
5.
Plug in -1. Tell me what you get for the other 2's. Other 2. Go. Fill it in. Go. There we go. How about for -1? -2 and -2. -2.5. Good. So plot these points. We'll start at 2, 5, 1 and 1, 0 and a -1. Right there. -1, -2, 2, -2.5. So Amelia just asked, is this one of the ones where you would maybe plot additional points to find out where the asymptote is? Because it doesn't really give me a clear picture. Yes and no. Yes, you can. Or, Alex, where is the asymptote for this? On A. Where is the actual asymptote? Do you know where it is? Y equals what? -3. How do I know it's -3?
It's your K.
Because that's K. So you are more than welcome to plug in additional points, or if you recognize at this point, actually my asymptote is, and this is where you will draw a dotted line, even if it's without blue ink, okay? Y equals -3 is where my asymptote is. Meaning I can go ahead and crudely draw.
So is it also basically where the last point is?
Give me the last one.
Well, like,
Yeah, and that's where, if you didn't know that -3 was K, and that's where it was, that's where Amelia did the right thing, says plug in more numbers so you know what you're getting close to. We'll see that really clearly on this next one. Alright, so domain, folks, domain for this, Victoria, that's domain. Domain, all real numbers, good. Range, Ashton. Not equal to. It can't be equal to because an asymptote is never equal to. But good has to be greater than -3, right? My asymptote's at -3, so I have to be everything greater than that, and I cannot be equal to -3. We'll take off points if you put an equal sign as well. Gotta only be greater than. That's the definition of an asymptote, guys. Can get close to but can't touch. Cue the MC Hammer. Is it what? Oh, yeah. So then I have a horizontal asymptote where y equals -3. Good. All right, do the last one. Hint, use decimals, go. So I got 7, 3, 1.7, 1.2, 1.07. It's 1.074. I'm all right with 07. The important thing, guys, somebody asked me, well, why can't I round this to like 1.1? Or if I'm going to round, if I keep going, like if I kept going on this and I did 4, and I'll get 1.008. Well, if you were going to round that, you could round that technically to just 1. But you can't do that because of asymptotes, right? Your asymptotes have to be reflected in your rounding. So, if I graph this, -2 and 7, -1 and 3, 0 and 1.7, 1 and 1.2, 2 and 1.0074. So I have a horizontal asymptote at y equals 1. Could you have told me that completely based on k?
Yes.
Yes. And that's fine, but when we're graphing, I'm going to ask you, just like you graphed on this last test, I'll even give you that chart. Maybe I won't. Either way.
Don't give us the chart.
No, I like giving you the chart. It's better, right? Either way, you've got to give me points on that chart.
I also think it was the one
Fine.
the already graph that.
Oh, instead of literally just axes.
Yes.
Yeah, no, it's fair enough. So,
Please do that.
oh, sorry. So domain on this guy, all real numbers again, right? Range, Colton? Y is what? Less than 1? Greater than, right? I'm always above 1 in this. Y greater than 1, and I have a horizontal asymptote at y equals 1.